Good morning, good afternoon, good evening, and welcome to another science post. This one is on geothermal energy and the weather. The Wikipedia on the amount of heat produced by and reflected by the Earth says, despite its geological significance, this heat energy coming from the Earth's interior is actually only 0.03% of the Earth's total energy budget at the surface, which is dominated by 173,000 terawatts of incoming solar radiation. The author cited concludes that since there is 173,000 terawatts of incoming solar radiation, climatologists can ignore the internal energy of the Earth in their models of global warming. I don't think this assumption is correct. There is heat coming from above and heat coming from below, but which heat source will the water absorb more efficiently? The energy coming from underneath, usually. This is why we put a stove underneath a pan of water. We do not hold it at a distance above the surface of the water. Just try boiling some water with the stove positioned above the pot. That won't work. This suggests to me that the climatologist referenced, the government-funded climatologist referenced in the wiki, was a fool to neglect the contribution of the internal energy of the Earth in his climate model. But what can we salvage from NASA's model of the climate? There is a nice graphic from NASA on the Earth's Energy Budget Wikipedia page, and you see two different calculations. One in yellow about the incoming solar radiation and the amount reflected from the Earth, and the other from the Earth's perspective about the amount of energy emitted by the surface and reflected from the sky. So the picture describes two ways to calculate how much energy is absorbed by the atmosphere, and you can calculate the absorbed energy from the sun's perspective or from the Earth's perspective. From the sun's perspective, the sun drives climate change, but from the Earth's perspective, the greenhouse gases like water vapor determine climate change. But is the sun the only factor determining how much water vapor is in the air? Water vapor is by far the primary greenhouse gas, and if climatologists are neglecting, for example, the heat generated by the Earth in their estimates of how much water vapor will be emitted by the oceans, then they're making a big mistake. A solar picture says, if you just focus on the sun alone without any focus on the Earth, the sun would, from the sun's perspective, you'd say that the net absorbed energy from the sun is 600 milliwatts per square meter. But from a geothermal perspective, coming from the inside of the Earth, you would see that hundreds of milliwatts per square meter get pumped into the ocean from geothermal sources. And in the blog post linked below, you can see some nice maps of this. So this tells me that the 0.1% changes in the heat from the sun over 11-year sunspot cycles influences the climate by a small amount. But given the efficiency of thermal conduction in the oceans, I would think that changes in the geothermal output could have a comparable climate effect by heating the ocean. Yet, why do climatologists minimize this? It's weird. The El Niño cycle seems like a perfect example of this, as in the zones of heating and cooling in the Pacific Ocean that drive the El Niño cycle. They are packed with underwater volcanoes. And yet when you look for government-sponsored models of El Niño, you hear no mention of underwater volcanoes. Are they trying to hide this fundamental cause with complex smoke and mirrors? A larger impact on the climate that is not included in NASA climate models comes from the impact of solar magnetic fields on cloud formation. Consider the possibility that when the sun's magnetic field is weak, the Earth's core generates more heat, and this causes undersea volcanoes to heat the oceans enough that they send more water vapor up into the atmosphere to make clouds. From this perspective, one need not puzzle over how the size of water droplets depend on the strength of the solar wind, as has been done recently by CERN researchers. I think that they have confused causation and correlation. Cloud formation is correlated with changes in the solar wind, but it is not directly caused by changes in the solar wind, as their hypothesis suggests. This sort of research seems like yet more smoke and mirrors that hides the true, quite simple mechanism of climate change with El Niño and underwater geothermal heat sources. Am I implying that I think I understand this topic better than NASA and CERN? Well, maybe. When I quit my job as an accelerator physicist and was allowed to use my mind again, I noticed that there are a lot of stupid thought leaders funded by the government and by the media as well, and that most people are obedient, non-thinking little ants in a hive that often lacks a central intelligence. So you can end up with groups that are quite stupid, even if individuals within the group are capable of being quite smart if they are given the time to think, which is something that our economic system is designed to prevent. I think that this situation has come about due to a crucial flaw in present-day science education: the reliance on testing students on the application of formulas and memorization of definitions without allowing them sufficient time to develop deep intuition about the systems they are studying. Without knowledge of a detailed narrative connecting the formulas and definitions together, the knowledge is worse than useless. In fact, it gives the illusion of comprehension where none exists. When the sorts of people who lack the ability to construct layered narratives and who lack the ability to understand where their blind spots may sit, When these people end up in positions of power, the result can be quite disastrous. For this reason, I believe that science classes should stop testing students with multiple choice exams or exams that require a myopic derivation of a formula. The tests should instead take the form of a detailed narrative that requires the student to express a concept in multiple languages. The language of math, but also the language of words. And even there are multiple languages of math for certain systems, and they should all be understood in parallel. These sorts of tests are more time-consuming to grade, but when we have a surplus of people with academic credentials, we should put them to work as teachers. Of course, at the moment, from what I've seen on the internet, many people trained in the system are not aware of what they don't know, and they've been trained in a very myopic, compartmentalized way, and correcting this education may take quite some effort and some time. So I think that one of the reasons that teachers have become so myopic and compartmentalized is that we've attempted to make instruction more efficient by creating superhuman multitasking teachers and professors who rely on the internet to supplement their knowledge base. And from what's available on the internet, this is a very dangerous situation in terms of our ability to pass forward a sensible narrative. When I was working as an accelerator physicist, I was required to wear too many hats: teacher, computer programmer, engineer, technician, cleaner, marketer, writer, etc. And when people are trained to be jacks of all trades but masters of none, they learn to trust other people without trying to understand the big picture. This protects the power and knowledge of those who have access to the big picture and who have access to the time to understand that picture. This perhaps improves the efficiency of some workers in industry, but it is no way to conduct science. And big science, large projects building large machines, are based on exploiting these sorts of efficiencies. And I think this has had disastrous effects on our ability to identify when the scientific method is being appropriately employed. And by the scientific method, I mean the method used throughout history to make sure that we are not fooling ourselves with faulty logic. Of course, a person from the past may think I am silly for complaining about being trained to be a jack of all trades but master of none, because so many people from the past had to do very boring work that had no variety, just sitting in a factory and moving one thing from point A to point B all day. But I think that this misses the problem that we've built into our modern systems, that we need more people with a wider, more general perspective within the sciences. So, thank you for watching, and please tune in for my next video.